Okay, so now in this lesson on rational exponents, part one, we're going to simplify rational expressions in which the exponents are positive rational exponents. Now, in a previous lesson, you learned about these expressions: 4 squared, 3 cubed, x to the fifth power, and so on. So notice that these exponents here are rational exponents, so they are rational exponents, but they're whole numbers, 2, 3, 5, so they're positive integers. All right, and we know that 4 squared here means 4 times 4, which is 16, and we know that 3 cubed here means 3 times 3 times 3, which is 27, and here we can't simplify x to the fifth, so we're just going to leave it as x to the fifth. But what we're interested in now is this. We're interested in, well, what does 3 to the 1 half mean? What does 4 to the 1 half means? What does 3 to the 1 fifth means? And so on. X to the 2, I'm sorry, let's make it x to the 1 6. Negative 9 to the negative 1 fourth. Things like that. Now, here, in this one, we're only interested in positive rational exponents, but in the next lesson, we're going to look at, well, what happens if it's negative? But notice that these exponents are not positive integers. They're rational numbers. So they're fractions. And in this particular case, we're looking at rational exponents where the numerator is 1. So 1 fifth, 1 half, 1 half, 1 sixth, and so on. Okay? Okay, so we got to talk about, well, what does that mean? How do we deal with an expression that has the exponent being 1 half? We all know how to deal with the expression in which the exponent is a positive integer, but we've never dealt with it that looks like this. What does 3 to 1 half mean? What does 4 to 1 half mean? And so on. Okay, so to kind of talk about how to deal with that kind of exponent, let's look at this for a moment. So let's suppose this. Let's suppose that x equals 5 to the 1/3. Okay? Just take for granted that I'm telling you that x equals 5 to the 1/3, and you're going to see in a little while what all this means. So x is 5 to the 1/3. Now, I am going to rewrite this right here, and I'm going to cube each side. So mathematically, if I can square both sides, I can cube both sides, I can raise both sides to the fourth power. Mathematically, that's still correct. What I do to one side, I do to the other. So I'm going to go ahead and cube this side, and I'm going to cube this side. And so what's going to happen is that this right here, right here, I'm going to go ahead and write this as x, let's see, 5 to the 1/3 times 3. So remember, the product rule, I'm sorry, the power rule says that when you have a power raised to power, you multiply. So 1/3 times 3 is going to be 1. So it'd be 5 to the first, which is 5. So we have this. We have x cubed equals 5 here. So if if x equals 5 to the 1/3, then if I cube both sides, it turns out that x cubed has to equal 5. Okay, just based on this. All right. Now, so remember in a previous lesson, we learned this. We learned that if x squared equals 4, and if x squared equals 4, then to get x by itself, I'm going to take the square root of 4. So I'm going to do this. Now, obviously, we would do the plus or minus also, since this is an even root. That was in a previous lesson. So I get that x equals plus or minus the square root of 4, which would be plus or minus 2. Now, using this idea here, to get x by itself, right now I'm cubing both sides, and the opposite is to take the cube root. So I'm going to go ahead and rewrite it right here. So I get x cubed equal 5. So if I take the cube root of both sides, now remember, you only do the plus or minus if you're taking an even root. This is an odd root, so you leave it as just a positive cube root. So the cube and the cube root into each other, so you get x equal the cube root of 5. And the whole point of all this is for you to see this now. X right here was equal to this. So we have x equal 5 to the 1/3, but x is also equal to the expression that looks like this, which equals the cube root of 5. So here's the point. This is what we're going to look at now. All right, so this is what you have to remember. Okay, so we have this. We have 5 to the 1/3 is going to equal, is the same as saying the cube root of 5. Okay, based on all that we just did. Now look at this rational exponent. So we can always go from a rational exponent to a radical expression. We went from a rational exponent to a radical expression. Okay, so we went from an expression that had a rational exponent to an expression that now has a radical expression. All right, now here's what I want you to notice. You see this denominator? The denominator, when you rewrite it as a radical expression, the denominator is your index. The denominator is your index. So note, the denominator of the rational exponent becomes the index of the radical expression. Okay? All right, so the denominator of your rational exponent becomes the index of your rational expression. So here's the definition I need for you to remember. So the definition of a to the 1 over n. All right, so the definition of a to the 1 over n. Now we are assuming that in this case, remember in this part right here, let me remind you, in this part we're assuming that we're dealing with a positive rational exponent. Okay, positive rational exponent. So the definition of 1 over n. Now we're assuming again, assuming A-S-U-M-I-N-G, that n is positive. N is positive. Okay, so that means n is positive. In the next section, we're going to talk about what happens if we have a negative exponent, but this is only dealing with n is positive. Here's the definition. So if n is a positive integer greater than 1, and I should say greater than 1, n is a positive integer greater than 1. Okay? So 2, 3, 4, so on. So if n is a positive integer greater than 1, then I can rewrite this as the nth root of a. So if I have a raised to the 1 over n, then that's the same thing as saying the nth root of a. So basically a to the 1 over n equals the nth root of a. Now again, that's assuming that n, remember right here, we're looking at 1/2, 1/3, 1/4, 1/5, 1/6. So it's assuming that your denominator of the rational exponent is a positive integer greater than 1. Okay? All right, now let's use this. So the directions is going to say this. The directions is going to say use radical notation. Use radical notation to write the following. And then simplify, if possible. Okay, so that's your direction. Use radical notation to write the following, and then simplify if possible. Okay, number 1. We have 36 to the 1/2. 36 to the 1/2. Now, don't use your calculator with this. You got to understand this. So don't use your calculator. So 36 to the 1 half. Well, according to this, 36 to the 1 half, remember that's the exponent is a rational exponent and it's written as 1 over 2. So the numerator is 1, so I can use this definition. So according to this, that's the same thing as saying the square root of 36. Remember, your denominator is 2, so that's your index. And from a previous lesson, we know that that's just, we can simplify. So first of all, note that this is my radical notation. This is your radical notation. So if it says what's in the radical notation, that's what you need to write. And then simplifying, here's the answer. That's simplified. Okay? All right, number 2. Suppose we had suppose we had 1,000 to the 1/3. 1,000 to the 1/3. Well, that's going to be the cube root of 1,000. So what number times itself 3 times is 1,000 is what you're asked. Same thing here. What number times itself 2 times is 36? Well, 6 times 6. So the answer is 6. Here, remember the numerator is 1, so I can use this definition. The denominator is 3, so that's going to be the cube root. So that becomes your index. Okay, so what number, without using a calculator, think, what number times itself 3 times is 1,000? Well, it's going to be 10, because 10 times 10 is 100, and 100 times 10 is 1,000. So the answer is 10. Notice this is your radical notation. Radical notation, that's what you put in the blank. Radical notation. And this is the simplified answer. Okay, number 3. We have x to the 1/3. X to the 1/3. Well, notice that, first of all, if I write it as radical notation, that's going to be the cube root of x. And that's a variable, so I can't do anything with it, so I'm done. So that's your radical notation. It's also simplified. So they ask you, what is it in radical notation? Blank, and then simplified, blank. You would put cube root of x, cube root of x. You can't simplify it, so leave it as cube root of x. Okay, number 4. Suppose we had this. Suppose we had 1 to the 1/4. 1 to the 1/4. Well, again, that's the same thing as saying the 4th root of 1. Your base is 1, so that becomes your radicand. So the 4th root of 1, so what number times itself 4 times is 1? Well, the answer is 1. Number 5. Suppose you had negative 64 to the 1/2. Okay, so let's kind of review something before we do that one. So remember, there was a difference between negative 6 squared versus this. It looked like this. So this negative 6 was your base, and over here you got to remember what your base is. Since there's no parentheses there, then the only thing being squared is the 6. So here, this meant negative 6 times negative 6, which is 36, and here, the only thing being squared here is this 6. So 6 squared is 36, so the answer here is negative 36. So we're going to use that idea here. Okay, so remember though, this is a rational exponent, so you're going to rewrite as a radical. Okay, now be careful. The base here is 64, not negative 64, it's 64. So when you rewrite as a radical, you're going to say the square root of 64. So you get negative square root of 64, so that's your radical. That's your radical. And then simplified, that's going to be negative 8, because 8 times 8 is 64. So that's simplified. Okay. Let's look at this one, number 6. All right, suppose we had, in parentheses, 125 x to the 9th raised to 1/3. Okay. Now, before we do that, let's remind ourselves, let's review something from a previous lesson. Suppose you want to simplify the square root of x to the 4th power. Now let's assume that all the variables represent positive integers, positive real numbers. So all variables represent positive real numbers. So that way we don't have to worry about that absolute value. Remember in the previous lesson, we had to deal with absolute values. So let's just assume that all these variables here are going to represent positive real numbers. So remember, um, the square root of x to the fourth, remember that's just x squared. So remember that previous lesson, you asked yourself what times itself twice, because your index is 2, is x to the fourth. Well, what worked was x squared times x squared. So that's how we got this x squared. And then basically you also saw this. If my index is 2, you said 2 into 4 is 2. So you get x squared. Okay? And so if you look at another one, let's say we had the cube root of x to the ninth. Let's do 12th power. Cube root of x to the 12th. So you ask yourself, what times itself 3 times is x to the 12th? Well, what would work would be x cubed times x cubed, sorry, x to the fourth times x to the fourth times x to the fourth. Okay, because 4, when you multiply like base, you add exponents, so 4 plus 4 plus 4 is 12. And so the answer would just be x to the fourth. So remember what you did, though, you said 3 into 12 is 4, so that's how you simplify that. So that was from a previous lesson. All right, so here we're going to do the same thing. We're going to rewrite this. Remember, rational exponent 1/3 means the cube root, so that's going to be the cube root. And the whole thing, see how this is in parentheses? And over here, there was no parentheses, so it's just 64. So this whole thing in parentheses is you're taking the cube root of. So the cube root, make sure you put index 3 here, 125 x to the 9th. Now let's simplify each part. So remember, that's going to be the, you could have done this in your head, but that's going to be the cube root of 125 times the cube root of x to the 9th. So what times itself 3 times is 125? Well, the answer is 5. So it'll be 5 times. All right, now simplifying the cube root of x to the 9th, what times itself 3 times is x to the 9th? Well, the answer is x to the 3rd. You can easily see this because 9 divided by 3 is 3. So the answer is 5x cubed. Now in terms of what to put in the blanks, you would say this. So your radical notation, make sure you understand what goes in the blanks, would be this part here, the cube root of 125 x to the 9th. The answer for simplified would be this right here, 5x cubed. Okay? All right, let's look at this one, number 7. You have 3x to the 1/4. 3x to the 1/4. So, so again, the only thing that's being raised to the rational exponent to the 1/4 is this x. If it was 3x, you would have that in parentheses. Okay, so you got to be a little bit careful. So the only thing being raised to the 1/4 power is the x. I'm going to change this part right here to radical notation. So I'm going to get 3 times the 4th root of x. So 3 times the 4th root of x. So that's your radical notation. So your radical notation is 3 times the 4th root of x. Now in terms of simplifying, this is just a variable, so you really can't simplify like we did these. The 4th root of x, that's nothing else you can do. All right, so there's your answer for radical notation, and so you can't simplify. So if you have the simplified answer here, just put in the blank the same thing. So 3 times the 4th root of x. All right. Let's see. Let's do a couple more. Okay, so let's suppose we had this one. Suppose we had number 8. Negative 16 to the 1/2 power. Negative 16 to 1/2 power. Okay, so now we talked about complex numbers and imaginary numbers in a previous lesson, but all they want you to do here is this. If it's not a real number, just say not a real number. So first of all, though, this is going to be the square root of negative 16, And you would say that in terms of simplifying, so there's your radical notation, first of all. That's the radical notation. And then in terms of simplifying, you would say not a real number. So in MyMathLab, when you do this, you would say not a real number. Now we get to another section when we did the complex numbers, the imaginary numbers. Remember, that's what you put. But remember, though, note the square root of negative 16 you can write as 4i. But in this section, we get to MyMathLab. Make sure that's what you put for the simplify. You'd say not a real number. So here's your radical notation. Simplified, not a real number. Okay? All right, now, okay, so that's going to end this part. So basically, all you need to do for part one now, this is just part one, was understand this idea here, that when you have a base raised to a rational exponent and it's listed as 1 over n, notice the 1, it has to be 1 here, then I can rewrite it as the nth root of the base. So the base is a. All right, so for example, 36 to the 1/2, I can write as the base is the denominator of your rational exponent is 2, so that becomes your index. So my base is 36, so that's going to be your radicand. So you're going to say the square root of 36. Here you're going to say the cube root of 1,000. You're going to say the cube root of x, and so on. Okay, so that's all I need you to learn from this part, and that's only this part. Okay, so that was simplifying rational exponent expressions containing rational exponents using this definition. All right, that's going to end this lesson.